Okay, we're going to see how to hook up these resistors to a breadboard. And we've got 4 resistors out of our kits. These are the values, 147, etc. So make sure that you have these values and double check them with an ohm meter to make sure you have the right values. So the goal is to hook R1 and R2 in series, and that is going to be placed in parallel with R3 and R4, which are in series. So we have 2 parallel branches here. It's a series parallel combination. And we're only going to be applying 5 volts. So we'll be using our variable power supplies and not our 9-volt battery that we have in our kits. So let me say a couple things about the breadboards. This bus is tied together and this bus is tied together, but these buses don't cross over this barrier. Okay? And if you place a load inside of a common bus like we have here, you have created a short. It's no different than putting in a jumper right across your load. So we're going to connect our first resistors R1 and R2, and we're going to highlight each connection in our drawing as we make each one of these. So you connect one leg of R1 to, in this example, point J1. And in the drawing, we would highlight that part of our resistor to show that it's landed in the breadboard. And I just put J1 here. We normally wouldn't do that, but I've placed it here just to show where it's landed. The other side of this resistor now goes to I7. You see here I highlighted that and I noted it here. Now this R2 is going to be placed, so we've made this connection. One side of R2 is now in J7, and that bus, row 7, is a common bus, is all tied together. So we have tied one leg of R1 with one leg of R2. And this drawing is now showing that. I've highlighted those 2 points together, and just for reference, I've placed the points where each of these resistors have landed. Again, we normally wouldn't do this part. Now I'm going to land the other leg of R2 to J14. Here's J14. I'm going to highlight that connection and reference that point right here. Now we want to create our next series circuit. That's R3 in series with R4. Notice that now I don't have those reference points up here anymore, and normally in a drawing you wouldn't. There's many ways that we can connect this, and it would be up to the user on how they're going to do that. Now I'm going to connect one leg of R3 to point F1. F row 1. Well, row 1 is one common bus, all tied together. So we have now connected one leg of R3 with this leg of R1. So I can highlight that connection and highlight this bus, because these are now tied together. The other leg of R3 goes to point F6. Remember, row 6 is all tied together, so we didn't really connect to any other device. We just landed the leg in the breadboard. Now we're going to connect R4 to G6. Again, 6 is one row, so we have connected one leg of this resistor to one leg of, or the other leg of R3. So I can highlight that connection point. My last connection is the other leg of R4 to point F14. 14 row is all tied together, so I've tied this in with R2. and I can highlight that accordingly. Those are connected. Now I need to check to see that I make this circuit correctly before I apply power. So we're going to use Ohm's law, determine what our total resistance should be, connect our ohm meter up in place of where our power would be put in. Now my ohm meter read 89.2 ohms and I calculated 89.77. Close enough. I can now apply power, my positive and negative, from my 5 volts to my circuit. After this is completed, we'll start taking voltage drops measurements.